Hello everyone, welcome back to our channel. Let's discuss the next name reaction, that is Curtius rearrangement. So this is also an example of rearrangement reaction. Let's see the statement. Thermal decomposition of acyl azide into isocyanate with loss of N2 gas is commonly called as Curtius rearrangement. In this rearrangement, the reactants are acyl azides. What are the reactants? Acyl azide means N3 or not. Acyl means RC double bond O. So the general formula is RC double bond O N3. Acyl azide. This is subjected to the decomposition under which condition? Thermal condition. Okay. Produces isocyanate. See this one. RN double bond C double bond O with the loss of N2. Then how it become rearrangement reaction? How can we say that it is an example of rearrangement reaction? See this one. If you see the reactant, that acyl azide, in which the R group attached to carbon or not? R attached to carbon. But in the isocyanate, the R group attached to nitrogen or not? It means the shifting of R group from the carbon to nitrogen. That's why this is an example of rearrangement reaction. Generally, we know that isocyanates are the intermediates or not. So Curtius means only azide to isocyanate. But we need to do something with this isocyanate or not. That's why what the people are doing, initially these isocyanates are treated with the water. So R N double bond C double bond O. So initially water means HOH or not? That H will come here. The OH will come here. Okay. Again do the hydrolysis. What will happen? The another which H will come here. The another OH will come here. And this is subjected to cleavage or not? So RNH2 plus this one is H2CO3. So what are the major products? Primary amines or not? See this one. Isocyanates when treated with water, we will come up with primary amines. Similarly, if the isocyanates are treated with alcohol, see this one, if it is alcohol, means ROH. So RO minus H plus. The H plus will come here, then OR will come here. These type of compounds are called as carbamates. Similarly, if these are treated with amines, we will come up with urea derivatives. So in this way, we can convert the isocyanates into either primary amines, carbamates or urea derivatives. Okay, now the question is, how can we synthesize these kind of acyl azides? What are the methods which are available to convert the initial compounds into the azides? The compounds are carboxylic acids. So what the people are saying, from the carboxylic acids we can synthesize a variety of acyl azides. Here are the three best methods of preparation for the acyl azides. First, see this one. Whenever the carboxylic acid is treated with thionyl chloride, what happens? The OH is replaced with Cl. So these products are acid chlorides or not? Acid chlorides are treated with sodium azide. NaCl will be removed and we will come up with the corresponding acid acyl azide. If we want to do the direct conversion of carboxylic acids into the azide, we are having a reagent called as DPPA, diphenyl phosphoryl azide, that converts the carboxylic acids into the corresponding acyl azides. Otherwise, the third one is carboxylic acids may treated with the hydrogen. Initially what happens? Hydrogen from the nitrogen, OH from the carboxylic acid is removed in the form of H2O. Thereby RC double bond O, NH will be formed. Whenever this one is treated with nitrous acid, We will come up with acyl azide. So in this way, we can convert the carboxylic acids into the corresponding acyl azides. Okay, here we have two types of mechanism, thermal mechanism and photochemical mechanism, right? In case of thermal mechanism, what happens? See this one. Already we know that this is the acyl azide, right? N minus is forming the triple bond here. Here nitrogen valence is increasing. That's why the pi bonding electrons move towards this nitrogen. So this nitrogen will take minus charge and positive charge is there. Triple bond is formed and this one will be the neutralized. Right? In this particular process, nitrogen needs to be removed or not. That's why what is happening, see this one. The single bonding electrons moving towards this nitrogen means we are giving minus charge to this nitrogen or not. Already plus is there, minus and plus will be neutralized or not. Thereby which one is removed? N2 is removed or not? Now, because of the transfer of these electrons towards this nitrogen, the positive charge will be developed at this nitrogen or not. Okay, remember that here we have created the positive charge by the removal of N2. Okay, that is the first point. Now the second point is the N minus is forming the pi bond between carbon and nitrogen. Already see double bond O is there, 2 bonds and 2 bonds. The carbon valency is 4 or not? Now because of the R group, 5 bonds will be present or not? So in order to satisfy the carbon valency, what should we do? We need to remove this R group. Okay, how this R group will be removed? In the form of R plus or R minus? Already we know that in the first point, by the removal of N2, we are creating positive charge here or not? The positive charge needs negative charge or not? That's why the R is removed in the form of R minus and approaching towards that N plus. Thereby Rn double bond C double bond. This can be subjected to further treatment for the formation of primary amines, carbamates or urea derivatives. Okay. In case of photo rearrangement, what happens? The first situation is common, the creation of N minus and N triple bond N plus. In the previous case, what happens? Direct rearrangement takes place here itself only. But in case of photochemical rearrangement, what is happening? First N2 will be removed. See this one, N2 will be removed. Here what happens? By the removal, it is creating positive charge here or not? So here positive charge is creating or not? The plus and minus will be neutralized to produce a lone pair. So nitrogen containing such kind of lone pair means those intermediates are called nitrene intermediates. To nitrogen we have added acyl group. That's why this is an example of acyl nitrene intermediate. What is this? Acyl nitrene intermediate. Now this is involving in the pi bond formation with the carbon. Thereby pi bond formed means nitrogen carbon valency is increased or not? See this, nitrogen is donating its lone pair electron means electron density at the nitrogen is decreasing or not? That's why positive charge will be developed at the nitrogen. Okay, here the valency is increasing. That's why to satisfy this positive charge, the R is removed in the form of R minus and producing the Rn bond, C double bond. Here there is no formation of any intermediate, but here acyl nitrene intermediate is formed. Okay, see one example. Acid is converted into corresponding azide by using DPPA reagent. Then initially this one is subjected to Curtius rearrangement. Curtius rearrangement produces what? Isocyanate intermediate. Now this isocyanate intermediate treated with methanol CH3O minus and H plus to produce the corresponding carbamate. So in this way, by using this rearrangement, we can get a lot of products. Okay. Thank you very much.